Within linear regression, we have simple regression, and then we have multivariable regression. Now, the only difference between these two is exactly what the name suggests. One is a single or at least a simple variable version of the other. So in simple regression, we assume the function has a form of y equals to mx plus c, where we only have one feature and we need to predict the continuous variable, which is our output. This is our input, and we need to find the optimal values of slope and bias. And these are the requirements and features of simple regression. Now, for multivariable regression, we are assuming multiple variables in the function. So we have y equals to m1x1 plus m2x2 plus mnxn. Basically goes up to mnxn plus c. Now, here it's the same concept basically, but here x1, x2, xn, basically from x1, x2 going all the way to xn, these are basically a set of features. So you see how in simple regression we have one feature, whereas in multivariable regression we have multiple features or multiple variables, which is basically what the name suggests, right? And these set of features is something we are already giving to the model. So our data set has multiple features which we give to a model, and then we expect the model to give us a prediction from these given set of features. So that is our y, which will be our prediction, same as the simple regression. And the difference is in calculating our slopes. So we will have m1, m2, mn. These are our slopes, and then our c is the same as bias. So basically everything that we just discussed in simple regression is the same as in multivariable regression, including we can have a similar cost function. We will also apply gradient descent. We also need to set the learning rate to optimize the weights and then decrease our cost, and basically that will get us to a point where we get an optimal values of slope and bias that will give us the minimum cost. It's exactly the same concept. The only difference is multivariable regression has multiple features and multiple variables that contributes to making a prediction within the model. So the only separate procedure or function we want to do for multivariable regression is because we have a larger number of features, and because all of these features can have different range of values. Basically, we want to make sure that these different range of values does not impact the learning process in a biased way, or the numeric values of these different ranges of features does not directly impact how much the model gives importance to any one feature. And for that, we need to basically have a process called normalization. And although it sounds fancy, what it means is just given any feature, you want to convert this to a specified set of range. So let's say we have features, we have different features, and one of the features has values of 1, 2, 3 and goes all the way till 10. This is just gonna put bar here so we know this is for multivariable. Let's say this is for feature 1. For feature 2, we can have a range of like 100, 200, goes all the way to 1000, and then we have feature 3 that just goes from 0.01, 0.02 and so on all the way to 0.08. Now we see the huge difference in the range of these features, right? So we don't want the model to be biased towards feature 2 just because it has a higher numeric value within its features. It doesn't mean that feature 2 is necessarily important for our model to learn the pattern. It doesn't mean that our output is impacted or is favored more by feature 2. It just means it has a higher numeric value, which is why we want to make sure we don't make this mistake of biasing towards a given feature. And so what normalization basically does is it takes all the values of a given feature and converts it to a specified range, let's say from 0 to 1, or another popular range is -1 to 1. And let's consider 0 to 1 for now. So for our feature 1, basically we will have for all of our features, basically we will have a range between 0 to 1. So we will have all of these numbers from 0 to 10 mapped to a range between 0 to 1, and that will be the same. Basically the range between 100 to 1000 will be mapped to 0 to 1, and the same for the lower values as well. Now you see, once we have all features normalized to 0 to 1, we can make a fair comparison between the actual impact of these features on our output variable, which is the salary in our case, and we're able to see that how these features actually impact, or how these features correlate to our output variable, and then our model learns and understands those patterns between them. So normalization in multivariable regression is important because it helps you scale all features to the same range, and same range is very important for our model to learn accurate correlations or accurate patterns between these features and the output variable. And there are a couple of ways you can do this. You can basically divide features by mean value. That's one way to normalize our features. Or the second option is to divide it by the range. Actually, sorry, I think we need to subtract it by the mean. And the second option is to divide feature values by the range of a feature. And what I mean by the range is basically its max value minus its min value. So this is the range of any feature. You get the range by subtracting the max value by its min value, and then you can divide all features by this range, and that will give you all values between 0 to 1. Or you can also choose option 1, where you can take the mean and then subtract all features by the mean value. So basically this is normalization, and it is recommended you do that before you start the training for multivariable regression. And it's multivariable regression is very similar after the normalization. It's actually the same as simple regression that we discussed in detail.